Okay, so let's talk about problem set C. In order to do parts 3 and 4, which I said I would do in the video, I needed to do part 1 because we're going to use the answer. So I wrote the answer to part 1 up top so you can check your work and see if you got the same thing I did. All right, now for part 3, find the coordinates of all points in the curve, which the tangent line to the curve at that point is vertical. So a vertical slope is undefined. And you get an undefined number when you get a number divided by 0. So what we're really looking for is for the denominator of my slope, which is that 3y squared minus x, equals 0. Now that will imply that the slope that I get is undefined. So this gives you a relationship between x and y. X is 3y squared. Now, the slope has to be undefined, but it also has to be tangent to the curve, which means it has to fit the original function. It has to actually have a point on the original function. So what I'm going to do is take this relationship, which describes all the points of the original function, and this relationship, which describes all the points that give us an undefined slope, and I'm going to solve for the things that do both. And I'm going to do that by treating these as a system of equations. So I'm going to take my original function, which is up here, this original curve, and I am going to replace all the x's in it with 3y squared. So I would have y cubed minus, not x, but 3y squared times y equals 2. And then I'm going to solve for y. So I'm going to multiply out, combine like terms, divide by -2, and take the cube root of both sides. Now the cube root of -1, don't be confused, it's not imaginary, because you can actually get a cube root that's negative, because number times itself, if it started out negative, it ends up negative. So the cube root of -1 is -1. So this would be the coordinate of a point on the curve where both the point is on the curve and the slope is undefined. So what I'm going to do now is take that number and plug it into the simpler of the two equations, of this or this, to figure out what x is. And it looks like this bottom one is the simpler of the two. So I'm going to plug in -1 for the x, for the y, and that'll tell me that x is 3. So my coordinates are 3, comma, -1. So again, you'll get a relationship that causes the slope to be vertical. You use that with a relationship that's the curve itself, and you treat it like a system of equations. So now, the bottom problem. We're going to find the second derivative of this original thing at a particular point. So my first derivative, if I wrote it in the Leibniz notation, would have looked like that. But I know a lot of us are more comfortable doing implicit differentiation when everything is in the Newton notation. So I'm going to go ahead and switch it over. And now I'm going to take the derivative of both sides. So the derivative of f prime is f double prime. And then I'm going to do the quotient rule here. So low d high, so the derivative of f of x is f prime, minus high, which is f of x, d low. Now this, the derivative of -x is -1, and the derivative of 3f of x squared would require the chain rule. You can pause the video here and work that chain rule out if you want. I'm just going to write what the derivative is. It's 6f of x times f prime of x minus 1 all over low. Now, that's the second derivative, and we got all sorts of stuff going on here, right? We've got f of x, we've got x, we've got f primes all throughout this expression. So the idea is we want to know the second derivative where x is negative 1 and y is 1. So for all of the f of x's, those were y's. So we're going to replace those all with 1's because that's what y is. And for all the places where you see just a regular x, we're going to replace that with negative 1. Now we'll talk about the f prime in a second. Now, we filled in all the x's, we filled in all the y's, and now we've got this f prime. So what we're going to put there is what f prime is whenever x is negative 1 and y is 1. So if I take that and put it into either this thing or this thing, y is 1 and x is negative 1, that's going to give me 1/4. So the value of each of these blanks is 1/4, and then it's just a matter of doing all the arithmetic. So then this would be 3 minus negative 1, which is 4, times 1/4 is 1, and I'm running out of room, so I'm going to push it up here. So this would be 4 times 1/4 minus 1 times, let's see, 6 times 4 times 1/4 is 6/4, which is 3/2, minus 1, which is 1/2, all over 3 times 1 plus 1, which is 4, squared. So if I simplify that, I get this. That is not a negative, that is a mystery. And 1/2 divided by 16 is going to be 1/32. So hopefully I did all my arithmetic correctly there, but that's essentially how you do the problem.